Every single plane at one of Europe's busiest airports grounded tonight. A drone, police say, is deliberately disrupting operations, leaving tens of thousands stranded.
Police in Britain say they're investigating an incident involving a drone and a passenger plane. This after a pilot reported that he believed a drone struck his jet before he landed safely at London's Heathrow Airport on Sunday. There don't appear to
We are going to be on that flight. I warn you, we are going to be on that flight because we were told by your own people that you were okay. So, you...
These are just a few examples of things that can go wrong when you have drone interference at an airport. Hi, my name is Brandon Uzinski, and with me here today I have my team members Andrew Heckler, Tucker Brown, and Ali Kazmi. We're going to discuss the ACRP design challenge regarding runway safety and drone interference at airports.
From April 2019 to June 2019, there has been over 700 sightings of drones flying in unauthorized airspace. This number has grown since 2017, when the number of sightings was just over 600. Drones in no-fly zones is a problem that is continually growing. This is a problem because when drones are sighted in an airport's airspace, there is the potential for interference in the telecommunications, which can lead to delays. This in the end, impacts the public as well as the airports. Drones are causing issues for airports, and little has been done to help solve this problem. This is why our team decided to come up with a solution to solve this growing problem. Our problem statement reads, our team is tasked with increasing the safety of pilots, passengers, and airport safety by determining methods to utilize drones effectively as well as preventing unauthorized traffic in no-fly zones.
After defining our problem statement, we knew we had a lot of research to conduct. Our first approach was to do an internet search of the history of problems with drone interference in an airport and the impacts they have caused. After that, we started drafting our solutions and reached out to Penn State alumni to get their input on our approach and further innovate our solutions afterwards. We found there were many options out there already employed around the world to prevent drone interference at public events, and we figured that we can possibly upscale these solutions in order to implement them in such a wide area at an airport. Our team determined that we needed to implement a two-tier system in order to safely mitigate drone interference in airports.
Since our prototype is too expensive for college students to physically develop and test, we decided to portray our solution through a storyboard. Our proposed solution includes the combination of a geofencing system along with a code transmission that will disable drones in prohibited areas. The geofencing system has already been implemented in airports, but we are proposing a system that will transmit a signal to the drones to disable them. This solution is innovative because it allows airports with existing geofencing systems to improve it so it has the capability of disabling drones. Our detection methods first started off as thermal or acoustic sensors, but interference was the issue that both detection techniques had. We found geofencing as the most reliable solution. To make our prototype more effective, we could determine how exactly the drones would receive and process the signal to make the transmission as efficient as possible. In the testing phase, we realized that a modified drone could easily pass through a geofence for a number of reasons. To prevent this, we came up with another solution that would act as a fail-safe to manually disable unauthorized drones via a code. Realizing that the drones can be modified post-production, we decided to implement a two-stage fail-safe where all drones are capable of being disabled and detected. This would include a visual and audio signal to the flyer and then disable the drone if need be. This two-stage system works because if a modified drone enters the airspace, it can still be disabled due to a signal that is transmitted at the proper frequency.
As you can see from our cost-benefit analysis, the cost of our solution is greatly outweighed by its benefits. We estimate that the cost of implementing our prototype, of setting up a geofence and having the ability to send a signal to drones which would activate the drone code to send it back to the home base would be a little more than $1.3 million. This cost is pretty insignificant compared to the benefits an airport would receive from implementing our solution. Whenever a drone is active in or near an airport, it can cost the airport and its stakeholders millions of dollars. This is because thousands of passengers can have their flights delayed in a single day. There are many risks involved with drones being active near airports. They can hit the airport, hit an airplane, which can be very catastrophic to its passengers. But as long as our prototype is functioning properly, there are very few risks involved. Most of the risks involved, such as a hardware malfunction, can be solved with mitigation. Our team defined engineering leadership as the ability to put teammates or coworkers in a position where they are able to innovate and able to succeed in solving engineering challenges. Throughout the semester, we had to maintain this style of leadership. During our team meetings, we would be sure that everyone's opinion was heard, so that they felt like their opinion mattered to our team, and so they would feel comfortable within the group. One of the most important things I learned about leadership this semester is that it is important to be confident with your decision making, but also to listen to your peers' feedback so that your team or company is able to be successful.